Alright, today we want to finish chapter 5 about triangles. The last leftover is 5.6, the law of cosine. So we were talking about the law of sine to solve triangles. We know to solve a triangle, we have 6 things of interest, 3 sides and 3 angles. Okay. Then through the law of cosine, the law of sine and the summation of the angles is 180 degrees. We were able to get 3. So in order to solve 6, we need to know 3 elements. Through the equations, we can solve the other 3. Okay. Then because we need to know 3 things, we have the following cases. The first one, we know 2 angle and the side, we have 2 cases, but really they all merge into 1 case. That is, once you know 2 angle, you know 3 angle. The second case, we have SSA. And we have SAS. We said for SSA, it's doable. Okay, but for SSA, where the angle is specifically the angle in between these 2 sides, it's not doable, and we need the law of cosine. The third case, when we know 3 sides, we don't know a single angle, again, we need the law of cosine. So we are going to handle these 2 cases by introducing a new law, the law of cosine. Okay, how do we do that? We still do the same thing as before. We mark everything to be the angle here, and the opposite to be the corresponding letters for the sides. Then, the law of cosine tells you the following. That is, which is very similar to a complete square, except you are going to times the corresponding opposite angle. If this is C here, you use the angle C here. Okay. Similarly, you have the other 2. If you know A, you can get it from BC. And angle A. And finally, if you have B, you can get it from A and C. So basically the other 2 sides for all these, and then when you finish, you times the cosine of the corresponding angle you have there. Depending on which side you know, you use one of these things to solve for the side you want, which is called the law of cosine. So exactly once you see that, let's take the first example. That means you know A and B, and you know the angle C. So that's exactly, if you can see, it's exactly the SAS case. So S, and the corresponding A is in the SAS situation. So of course, you can use the law of cosine to solve the case in this case. Shall we go over the proof? I will go over it briefly. Okay. So the first thing is probably we want to put the triangle into the coordinate system, and depending on how we name it, A, B, and then we call this C. Then this is going to be C, A, and B. Okay, so the triangle does not have to look like this way. I just put this one because it's easier to prove. Other cases, you can do it in a similar manner with additional work. So the first thing we want to do is we want to form a right triangle in this way. Okay, I'm going to call this angle, this point, O. Then it's very easy to see by Pythagorean theorem, A squared equals OC squared plus OB squared. Because we have a right triangle. Now second, what we want to do now is we want to redo these 2, and we want to associate them with BC. And let's not use A, let's use D. Okay, I want to use A for O for the origin. Oh, actually the origin is called A, so take it back. O is fine. Just keep in mind this is A. Okay. Now we want to associate OC and OB, all in terms of B and C, because that's what we need for the law of cosine. Okay, which is AC and AB. So let's do that. Number one, what is OC? OC is going to be B, and if you focus on this right triangle, okay, OC is going to equal to B, or let's do one addition, no step. OC over B equals sine angle A. Okay, therefore OC equals B times sine A. We can replace this later. The second one is going to be OB. Now if you look at this graph, OB is very easy to do. OB equals OA plus AB on the graph, and AB is nothing but our C. OA, of course, is related to B. Now if you write the same right triangle again, this is going to be OC times cosine. Let me try to make sure this is careful. What I hear is angle AOC. OAC. Not just angle A. Okay, OC equals B times sine angle OAC. Okay, this one is B times cosine angle OAC plus C, which is our AB. All right, now finally, keep in mind what we have here. When we draw the right triangle, as in the coordinate system, what we mean angle A is technically this one. That's angle A. And what we have in both of the former is the angle AOC. But the good news is the angle AOC plus angle A is going to be 180 degrees. Therefore, they should share the same sign and a negative cosine, the negative cosine. So to write it out, and you need probably some more time to realize what I'm writing down here. But basically, we can have sine, even though there are different angles, okay, and the cosine AOC equals negative cosine A. Because technically, cosine A is a negative thing because A is an angle in quadrant 2. But AOC is an acute angle, therefore it's positive. Now if you put these two things back into what we found there, finally, we can write down A squared equals, okay, OC squared plus OB squared. But we just figure out OC is nothing but B times sine angle AOC. OB is nothing but OA plus AB. Okay, but we did additional steps, which is nothing but B cosine AOC, OAC. Oh, OAC. What did I write down? AOC. OAC. Ho ho ho. Okay, plus a C square, and then use the fact we just wrote down here. We know we can safely replace this one to be A. We can safely replace this one to be A if we put a negative sign in the front. Okay. After that, it's just standard algebra. It equals B sine A, both squared, plus B squared cosine squared A, plus c squared minus 2bc cosine A by completing the square. Notice the first one can be merged together because they have the same term. It becomes b squared sine squared A plus cosine squared A. And as far as we know, this is equals 1. So finally we have b squared plus c squared minus 2bc cosine A. So it's a long proof, but really what you did is just you try to make a right triangle out of the regular shaped triangle and do the geometry. You got this. Okay? That's the brief proof, but we really don't care too much about the proof. We just need to know how to use the law of cosine. So let's do the two leftovers. We have the SAS first. Very easy. 2, 3, 45 degree. Before we cannot do it, now we can. Okay, so solve the triangle. Let's call each one A, B, and C. So B, C, and A. We write down sine A over A equals sine B over B equals sine C over C. And then we know this is 3, this is 45, and this is 2. And then we got stuck because no matter how you set up the equations, for example, these two, you will always see there are 2 unknowns. So in order to proceed further, at least you need to know one more. Now, the law of cosine. What does it tell you? Well, what do you know? You know B, C, and A. Therefore, we should really use the formula involving A squared, because that uses exactly the 3 things we were talking about. Okay. 2 squared plus 3 squared minus 2 times 2 times 3 times cosine 45 degree. That will be A squared. So your A is going to be this, which is roughly hold on. Okay, let's get the size of 2.12. So that's a simple application of the law of cosine. Once you have that, what you can do is you can put this one into here. And once you have that, you can easily see, okay, it's a classic. We can set this up, we can solve for sine B, and then we can do the sine inverse to find B. Once you find AB, you can find C. You reduce to Sss Case. Once you have one more S. Okay, so I will skip the rest. But I will just say continue to solve using the law of sine, because now you have the complete equation. So very easy once you know this formula. Okay, that's it. Now the third one is going to be the Sss case. So suppose you have a triangle which give you 2, 3, and 4. Therefore, okay. Now what you want to do is you want to solve the triangle. Clearly, what you're missing is an angle. Okay, so how can you get an angle from all the 3 sides? And clearly, the law of sine does not help. We only know all the numbers on the bottom. So we don't have a complete equation, which we can again assign and then try to solve for C or B. So we need something else. And we only have the law of cosine. So let's write down the law of cosine. You can do this one or the other two. Now what do you know? You know this, and if you know A, you can find the size A, but instead you don't know A before this time for the angle. You know the other one though. Then do you realize if you write down the law of cosine, you actually can focus on this one if instead you didn't know the angle but the size. It's just the same equation but solving a different variable. Okay, let's see how do we do it. A squared. Let's just try to not skip the steps. 2bc cosine A equals b squared plus c squared minus a squared. Therefore, cosine A equals, and as far as you can see, there's nothing other than the sides on the other side. So once you know the three sides, you will be able to do it. Minus 4 squared. All right. Which gives you 12. Okay. 9 plus 4 minus 16. Negative 3, which is negative 1/4. Now you know cosine A equals negative 1/4 if you apply directly the law of cosine. But this time, you don't know the size. Before, you don't know the size, you know the angle. But this time, you know the size, but not the angle. You can just solve it by solving an equation. Once you have that, what is A? A is going to be cosine inverse 1/4 negative related. Not necessarily the same, though. But if you draw it, like we said before, cosine is going to be positive here and a negative here. From here, you can see for a sine, whenever you have the sine value, you have two possible values from 0 to pi. Because these two angles, they share the same sign. They're both positive, right? But for cosine, you don't have two, you only have one, because it's either positive or negative, even though they may both give you 1/4, but only one of them give you negative 1/4. So this will be the answer. You don't have two choices. And that is roughly 104.5 degrees. Okay. That's what we get from the law of cosine. That's the first angle. The rest will be similar, but let's just try one more. What about B? Well, therefore, cosine B, you can do the algebra, equals a squared plus c squared minus b squared now put everything to the corresponding spot. C is 2. Like we said, just do the cosine inverse, because from 0 to pi you have some 1 to 1. You don't have two answers, only one answer. And that gives you 46, let's just use 46.6 degrees. Okay. Now you can repeat the same thing for the third, or you can simply say, hey, I have the first one, I have the second one, so the third one is going to be this one. Okay. All right. That's another way for us to use the law of cosine. That is, knowing the size and go back and find the cosine of the angle and take the cosine inverse to find the angle. The good news is, for sine, if you know sine b equals 1/3 or 1/2, let's say, you do have two possible answers. It's going to be 30 degree or 150 degree because sine is positive in the range of 0 to pi. So you have two redundant values. But for cosine, you just take the cosine inverse. You only have one unique answer. So we don't have to worry about how many cases do you have, two solution case, no solution case, anything. We don't have to worry about that. All right. That's it. We have solved all the cases at the beginning. AAS, ASA, law of sine. Two sides, you have two cases. SSA, the law of sine. SAS, use the law of cosine to find the third S, and then you have the SSA case. The last case, all the three sides, use the law of cosine in a different way. Okay, don't know the angle to find the sides, but use the other way, that is knowing the sides, to back solve the angle. All right. We need to show you some applications, and moreover, we need to define something new, which is from the common sense in real world, called the navigation. In real life, we want to tell people the direction. We can tell people with the 4 directions. Okay, east, west, north, south. And then you can tell people northwest, northeast, so which give you something like that. When you say northeast, particularly you mean 45 degree here and 45 degree here. Okay. But in real life, out of all the directions in 360 degree, you can have all kinds of directions. Now we want a quick way to tell people how to navigate from a position, which direction you want them to go. For example, anything like this, which does not have to be a 45 degree, so you cannot simply just say northeast. Okay. And this is where we use something called bearing. That is, you tell people the direction by the angle they are due from the north or the south. Okay, so you tell people how big this angle is, or if it's this direction, you tell people how big this angle is. This, or you tell people that. Okay, usually it's written like this. For example, if you are going at a direction with a 40 degree, then you tell people, well, you should go from the north 40 degree due east. Okay, so this is where you start. This is where you go towards, and this is how far you should go in terms of angles. Okay, let's try another one. What do you mean by S? S 30 east. This is S. This is east. So this is the direction you are trying to go. Okay, so when you try to, for example, fly an airplane, you see it in all those kind of Hollywood movies. It's like, I don't know, number 2. There's an enemy tower at your north 30 west. Then you know what they mean by now. You simply start from here, the vertical direction, and go to the left or the right, depending on you have the east or west. And finally, you just, go the corresponding angles you want. All right. With that in mind, let's try to solve a very interesting problem. Let's say we have 2 airports, airport A and B. Okay. And we know airport B just use B, is 300 miles away from A. At the bearing, north, 50 degree east. Okay, so think about it. Can you draw it? Here's A, here's north, here is east of 50 degree, and you want to go 300 miles to reach B. So this is the location we are talking about. Okay. Now you have a pilot. He starts from airport A, and then he flies straightly to airport B. There's no trouble, except he mistakenly fly due east. At 200 miles per hour for 30 minutes. So he picked the wrong direction. He should be flying this way, but instead he flies this way. For a while, until he realized I am going in the wrong direction. Okay, so when he noticed, his arrow. Now, what he needs to do is he needs to actually readjust his directions. You are supposed to go north 50 degree east, but instead he went east. Now, if you want to go back and go here, of course you cannot go north 50 east anymore. Otherwise, you're going to go in this way. Since you're already there, you need to adjust it back a little bit. It's still going to be northeast, but not 50 degree anymore. A little bit smaller than 50 degree. Okay, so now he is trying to adjust. Okay, now two questions. Number one, how far is him from B now? Not 300 miles anymore, a little bit closer, but not too much closer because you are going in the wrong direction. Second, which direction? What bearing should he head his plane to? In another word, which way should you drive? Which way should you fly? Northeast, northwest, things like that. Okay? So if you draw the graph, originally you want to go from here to here, just go like that without a mistake. But once you have the mistake, you went east instead, then you realize you start to adjust a little bit to go here. That's the case. Okay? Now, remember, when we try to solve a word problem, when you finish, you need to write your answer in words. Now let's look at what we have here. Can you see that we have a triangle? If we call this C, then what we have is a triangle like this. We know A, we know B, we know C, and we know 300. Okay. How far is him from B right now? So what you want is actually you want to know what is BC. That is a side. Okay. The second thing you want to know is actually which way should he drive. So what really you are looking for, you are going north. You're wondering how big this angle is. Okay, and you know this is 90 degrees, right? Therefore, you will know which direction you should be going as long as you know how big this angle is. That is, what is B? And then you use B minus 90 degrees to find the angle you want for northeast. So, north, E, and you need an angle which is B minus 90, which implies you should find B. So in a triangle, you need BC, you need B. Of course, you need to solve the triangle. Okay. Once you solve the triangle, you will be able to find all these. Great. Now to solve a triangle, you need three things. Remember, you need a side, an angle, and maybe an additional angle or side. Now, what do you know? Number one, you know this is 50. Then luckily, you know this is 40. So you have one angle, you have one side. Second, what do you know? You know this one drove to the east for 200 miles per hour, and he did it for 30 minutes, which is half an hour. So 200 miles per hour, for half an hour, you drove for 100 miles. So if I write it down, we know B equals 300, A equals 40 degrees, and finally AB, which is C, equals 100 miles, which come from 200 times 1/2. Okay, 30 minutes. Your job is to try to solve for A and B. All right, with everything in mind, now we know. Okay, this is a clearly SAS case, the law of cosine. Wrong. A square all right, B square, C square, times cosine 40. Not accurate anymore if we use decimal, which is roughly 0.77. Okay. So now if we take that, therefore A is roughly okay. So you have 300, and if you fly for 100, you should have 200 left. But you were in the wrong direction, so you still have 200 and an additional 32 miles left. Wasted. But either way, answer for A, he is this much away from all right. Now for B, let's put this to be A. For B, you are looking for the angle B. You already know A, B, and C, so it's very easy to see sine A over A, which you just find A, equals sine B over B. But sine A is sine 40. A, we just found it. Let's round it. Okay, we don't really care about the 0.05 mile. And then equals sine B over B, 300. .83. Therefore, our B should have two answers. Sine inverse B equal 56 degree. Therefore, your B can be either 56 degree or B can be 180 minus 56 degree. According to how we draw, 56 is not going to work. Probably we need to take the other one. Okay. Then (56 degrees). So if the whole thing is 124, what you have here is going to be 124 minus 90, which is 34 degrees. So the answer is he should fly towards north 34 degree east, according to what we draw here. That's the answer for B. All right. That's what we get from everything in the law of sine and the law of cosine, and now you can solve for any triangles. According to this example, you can see the application is everywhere. Okay. Think about it, you can build a computer which can automatically adjust and calculate those numbers for you. So every time if you make a mistake, the computer will suggest, wait a second, now you are 232 miles away from your destination. If you really want to go there, please adjust. Okay, so through all those kind of computations, if you automate the whole process, you have an automatic pilot correcting system. You can either use that thing to aid the pilot, or maybe you can use that thing to aid a missile. So everything becomes automated. All right. One last thing, very quick. Some nice thing called Heron's formula. This is what the formula says. If you know the three sides of a triangle, if you know A, B, C, but not a single angle, then the area of the triangle is going to be given by S, S minus A, S minus B, S minus C, and then you take the square root. That's what Heron's formula is. This is a very nice formula, and the reason is because if you just have a ruler, I give you any kind of triangle. If you just have a ruler, you can measure all the sides. And usually it's pretty difficult for you to measure the angle. And also, if you use the law of cosine to calculate the angle, you need a table of cosine inverse and sine inverse, which usually people don't carry. But the good news is, as long as you have a ruler, you don't need an angle measurement. You do not need a cosine or sine table. You will be able to find the area. And that is pretty neat. Okay? Has a lot of applications if you're doing some kind of field work where you need the area of a triangle. Why is it true? Now, if I just take anything here and I take this angle to be B, we do know that the area equals 1/2 AC and times the sine in between. In this case, if you pick AC, this angle here, right? Now, let's square both sides. Okay, and then once you square both sides, you can change this to be 1 minus cosine square B. The moment you can change everything involving sine to cosine, you can see this cosine B through the law of cosine. You can change it to be I will stop here, but from here you can see once you plug this one into this, the formula for the square of the area of A will be reduced to something only involves A, C, and B. There's no angle, only size. Now if you simplify that, you will get this formula. Of course, you need to take the square root, which is no surprising. Okay. By the way, I forgot to write down where S equals 1/2 A plus B plus C. So if you are interested, go ahead and try to finish all the algebra. You will be able to get the formula by yourself. For now, we just take it for granted and do a very simple example. 2, 3, 4. We don't want to bother to find the angles, but we can find the area. Okay? S minus A, S minus B, S minus C. Now if you think about it, by definition, S equals 1/2 A plus B plus C, which is 1/2, 2 plus 3 plus 4, which is 9/2. Okay, then this is nothing but 9/2 times 9/2 minus 2. Something is wrong. This is 5. This is 3. This is 1. So together you have 16. Which give you 4. If you want to simplify a little bit further, okay, so that's how you apply the Heron's formula, straightforward. All right. Some exercise, or I don't know, a fun fact for you to fun exercise to think about. Now, if you take out the map of the United States, or a map of any kind of country, okay, just pick one. They may have a weird shape like this. Now what you can do is you can cut them into triangles. And with a ruler, you will be able to actually measure all the sides of all these things, these triangles, right? And then use Heron's formula, you will be able to find all the areas of each triangle. Now if you sum all the triangles, then with the help of a single ruler, a calculator, or to the extreme case with paper so you can calculate everything by yourself, okay, you will, and a map of course, you will be able to find the areas of any country in the world, no matter how weird the shape is, because you just need to cut them into more triangles. Okay, so if you're interested, find a country on the map and do this Heron's formula for multiple times and try to see, is your calculation matching the record on Google? That will be a fun fact for you to think about.